Hi, I am Dr. K. Kannan, Associate Professor in Mathematics, the Department of Science and Humanities, Hindustan College of Engineering and Technology, Coimbatore. In this section, I am going to discuss about the higher order partial differential equations. In a partial differential equations is an equations involving a functions of two or more variables and sum of its partial derivatives. Therefore, a partial differential equations contains one dependent variable and more than one independent variables. That is in the form of z equal to f of x and y. Z is a dependent variable and x and y are independent variables. Simply, in a partial differential equations can be used the following standard notations denotes dou z by dou x equal to p, dou z by dou y equal to q, dou square z by dou x square equal to r, dou square z by dou x dou y equal to s, dou square z by dou y square is equal to t. Now, how to find out the solutions of non-homogeneous partial differential equations? Let us consider the second order non-homogeneous partial differential equation is of the form a naught dou square z by dou x square plus a1 dou square z by dou x dou y plus a2 dou square z by dou y square equal to f of x comma y. Here a naught, a1, a2 are constants. Generally, dou by dou x is equal to capital D, dou by dou y is equal to d dash. We substituting this d and d dash in this given partial differential equation. The above equations can be written as a naught d square plus a1 d d dash plus a2 d dash square into z equal to f of x comma y. Once converted in this form of f of d comma d dash into z equal to f of x comma y, we can solve these equations. We get the general solution is given by z equal to complementary functions plus particular integral. Complementary functions find out from LHS, to find particular integral from RHS. Now the complementary functions, just we replace d is equal to m and d dash is equal to 1 in the given non-homogeneous partial differential equations. We get in this a form of quadratic form m square plus a1m plus a2 equal to 0. Just we solving these auxiliary equations, we get the roots are m1 and m2. Depending on the roots, we have to identify the complementary functions. Next, to find out the particular integral. Suppose if the given the non-homogeneous partial differential equations is in the right side of the function f of x comma y, they have the different cases arise. The first cases is the given function f of x comma y equal to exponential function in this form of e power ax plus by. Here we use the substitution is d is equal to a and d dash is equal to b. In this second case, if given f of x comma y equal to trigonometry functions, that is x sine of ax plus by or cos of ax plus by, here in a particular integral substitution is d square equal to minus of a square, d dash equal to minus of ab, d dash square equal to minus of b square. The third type is f of x comma y equal to algebraic functions x power m, y power n form. In this case, first denominator we try to convert 1 plus x or 1 minus x form. After we take the numerator, we getting in this form of 1 plus x whole inverse or 1 minus x whole inverse. After conversion, we use the binomial expansion formula. 1 plus x whole inverse is equal to 1 minus x plus x square and so on. And 1 minus x whole inverse equal to 1 plus x square plus and so on. After expansions, in this term of d, capital D, we use the derivatives. 1 by d means integrations with respect to x. Similarly, in the term of d dash we have to use the differentiation partially with respect to y, and 1 by d dash is integration with respect to y. In this fourth case, this is a general rule. If the above three cases is failure, we can use the fourth type. First, we convert the particular integral in this form of 1 by d minus m d dash f of x comma y. It is also equal to integral f of x comma c minus mx into dx. We try to convert in terms of x, and we have to integrate with respect to x. We will get the required solutions of given non-homogeneous partial differential equations. For example, solve d square minus 2d d dash plus d dash square into z equal to 0. In this case, first to find out axillary equations, we replace d is equal to m and d dash is equal to 1. We get the axillary equation is m square minus 2m plus 1 equal to 0. We solving these equations, we get m is equal to minus 1 minus 1. The roots are repeated, so the complementary functions can be written as f1 of y minus x plus x into f2 of y minus x. Suppose the right side of the equation is 0, the general solutions of given partial differential equation is y is equal to only the complementary functions. Suppose if the given the right side is exponential form, for example, we consider the right side is equal to e power x plus 4y to find out the particular integral also. 1 by the given partial differential equation d square minus 2 d dash plus d dash square into e power x plus 4y. Here only exponential function. So the substitution is d is equal to a. So here a is for the coefficient of x. D dash is equal to b. B is for coefficients of y here. So the coefficient of x and y are 1 and 4. So we substitute d is equal to 1, d dash is equal to 4 here. So simply we getting the particular integral equal to 1 by 9 e power x plus 4y. Therefore, the solution of the given partial differential equation is z equal to complementary functions plus particular integral. Just we substitute the complementary functions in particular integral in the z, we get the required solutions. Now we take the another examples. D square minus d d dash into z equal to sin x into cos 2y. Here the right side of the function is trigonometry, so we can use second type. Here the axillary equation is given by, we replace d is equal to m and d dash equal to 1 in the given non-homogeneous partial differential equation. We get m square minus m equal to 0. So m into m minus 1 equal to 0. So m is equal to 0 and 1. Here the roots are different. So in this case the complementary function equal to f1 of y plus f2 of y plus x. Now to find out the particular integral. Before finding the particular integral, here the two trigonometric functions multiplying. So simply first of all we split it into the two terms in this given function. We know this the formula for sin a sin b equal to 1 by 2 cos of a minus b minus cos of a plus b. So here particular integral can be written as 1 by d d dash into 1 by 2 cos of a minus b. Here a is x, b is 2y. So cos of x minus 2y plus cos of x plus 2y. After, we know in this trigonometry functions, we know that the substitution is d square equal to minus of a square, d dash equal to minus of ab, d dash square equal to minus of b square. Just we substitute the corresponding values. Here a and b is equal to 1 and 2, and we get the particular integral equal to 1 by 2 cos of x plus 2y minus 1 by 6 cos of x minus 2y. Therefore, the required solutions of the given non-homogeneous partial differential equations can be written as z is equal to complementary functions plus particular integral. Now the applications of partial differential equation is, in this solutions of partial differential equations can be used in many different fields of science and engineering. For example, to solve the Laplace equation, heat equations, wave equations and so on. Thank you for watching these videos.